Hey, I'm Jeff Crawford for Journo.com. Since my last video, Education Through Video Gaming, went over so well, I'm going to take the opportunity to talk a bit more about that. Specifically, Minecraft and programmable logic circuits. Players in Minecraft have taken the opportunity presented by the game to build fully functional computers, and a fully functional scientific calculator. Last one is really interesting because you can see how big it is, and if you watch the display is pistons, in-game pistons that move in and out. And it's interesting because you can watch the lag from the computer, the virtual computer built in the game, and you can watch the lag of the computer running the game, trying to process it all. Which is very interesting. And this Minecraft players are actually following along the path of another game called Dwarf Fortress, which is a lot less popular, but someone created a computer, fully functional computer in that game before Minecraft even came out. Unfortunately, it's a very hard game that uses ASCII characters as graphics, which means like ampersands and letters. So it never took off in quite the way Minecraft did, but it's an interesting game in its own right. Now, how do they do this in Minecraft? Well, there's something called redstone dust, which, you spread it as basically a wire, and it comes in two values, energized and non-energized, which those with some basic computer knowledge will recognize as being the same thing as binary. And from there, you can set up logic gates. I've mentioned it, in the last video. There are several standard logic gates that people have worked out how to build in Minecraft. Here's a graphic for it from the Minecraft wiki. What these circuits allow you to do is set up a series of if-then statements. If this value is true, then this will happen. If this and this value is true, then this happens. If this nor this is true, then this happens. And, those of you that have had some basic computing classes will recognize this as the basics of modern computing. Basically, microprocessors are just a series of logic gates written small that allow your computer to do processing very swiftly. The circuits in the game are much slower than the ones on your circuit board, of course. Now, I got into how it was important for education. Well, this is sort of an engaging way to teach people how to make circuit boards and do electrical engineering. It's very similar. It's not exactly the same. For instance, the power source is a redstone torch in Minecraft. It runs out of power. The power won't carry past 15 squares. That's a little bit like resistance in real life. Like the power only goes so far before you have to boost it. And you have something called a redstone repeater, which boosts your power to another 15 squares. And it also functions as a diode, where it keeps the power going one way, which is, that's something that's from a real circuit, and it's adjustable, like a diode. So it's really interesting. So they have stand-ins for real-life engineering practices, electrical engineering practices. Now, they're not exactly the same. It's simplified. You don't get into, copper has different conductivity than aluminum. So if you're making a circuit out of copper or gold or aluminum or whatever your conductor is, your values are going to be different for each thing. So they don't have that. It's just the one thing. So that's a simplification. But the principles are the same. And it's a good standpoint because you can't really expect your 15-year-old kid to start dealing with this resistance for that and sine waves and conductivity and ohms yet, but you can give them a good grounding in circuitry and if-then statements, which honestly, that's something I didn't pick up till a college liberal arts class, which is something that I pretty much would have gotten if they'd ever bothered to teach me when I was in middle school. And given the way computing is these days and was becoming then, it's probably something education activists should look into teaching kids. So I just wanted to expand on Minecraft and the things you could do in it. Very impressive projects. I would never probably have the time to put in. As you can see from the scientific calculator, it's huge. And really not the reason I play video games. But, even just learning some simple on and off switches, like if I need to keep a door to protect my castle in the game from zombies, I could do a simple on-off switch. And that is a fundamental thing that could stand you in good stead in this era of computing. So I just wanted to expand on that a little bit more. So for Journo.com, I'm Jeff Crawford, and this has been an expansion of education through video games.